So imagine you're trying to push 48 gigabits of uncompressed video data across a 40-story skyscraper.
Oh, good luck with that.
Right. With standard copper wiring, you hit a physical wall almost immediately. The signal degrades, the picture drops, and physics just, says no.
Yeah.
So, okay, let's unpack this because our mission in today's deep dive is exploring a piece of highly specialized AV tech that actually shatters that limitation for you. We're looking at the Celerity UFO-8KH-TX HDMI connectors.
Yeah, and to really understand why this hardware is such a massive leap, we have to look at the exact mechanism of that physical wall you just mentioned.
The copper resistance.
Exactly. In a commercial environment, traditional copper HDMI cables suffer from severe signal attenuation. The electrical resistance of the copper simply degrades high bandwidth data over long runs.
Right, which historically meant installing like expensive boosters or active repeaters.
Yeah, or IP-based network workarounds.
And those inherently introduce latency.
Yeah. Right. They do, yeah. But these Celerity connectors just bypass that entirely. They support HDMI 2.1 up to a staggering 1,000 feet.
Wow.
I mean, we're talking a 48 gigabit per second data rate, which easily handles pristine 8K resolution at 60 hertz.
Sending 8K data over 1,000 feet is like trying to blast a fire hose of water through a garden hose across 3 football fields without losing a single drop.
That is exactly what it's like, yeah.
Because if we're relying on electrical voltage, the friction, the resistance of the copper blurs the signal until the display at the other end can't even read the ones and zeros.
Right, and what's fascinating here is how the Celerity hardware physically circumvents that friction.
How so?
Well, the TX, or the transmitter head, actively translates the electrical HDMI signal from your source into microscopic light pulses.
Oh, wow.
Yeah, it fires those photons down a 12-strand fiber optic cable, and the RX, the receiver head, translates them back into electrical data instantaneously at the display.
Here's where it gets really interesting, though. Because you're sending photons instead of an electrical current, you completely isolate the signal from electromagnetic interference.
EMI.
Yeah.
EMI.
And that is the crucial mechanism here. In a commercial space, running a standard copper cable past an elevator motor or a heavy-duty HVAC system induces rogue currents into the wire.
Which is exactly what causes static or dropped frames.
Yes. Light doesn't care about magnetic fields.
Which means a pure, uncorrupted signal path from end to end for you. That's how it perfectly supports demanding high bandwidth formats like HDR, Dolby Vision, EARC, and like full 4.4.4 chroma sampling.
So you see the exact brightness highlights the original video engineers mastered?
But wait, I have to push back here for a second.
Sure.
When you say 12-strand fiber optic, I immediately think of microscopic, delicate glass. How does something that precise survive being yanked through commercial walls?
That's a fair point.
I mean, installation crews drop things through ceilings all the time. You can't exactly baby a cable during a massive stadium build. Right, and this raises an important question about practical deployment versus lab theory. You'd think it would be fragile, but the engineering here is surprisingly rugged.
Really?
Oh yeah, the internal reinforcement gives it a 60-pound pull strength.
60 pounds.
Yeah, it's designed to handle the tension of being snaked through tight commercial conduits.
Okay, 60 pounds of tension on fiber optics is serious durability. But what about corners?
It features a very tight 0.5-inch bend radius.
Wow.
So sharp 90-degree turns inside a wall won't snap the glass. Furthermore, the entire cable is plenum rated.
Meaning for the airspaces.
Exactly. In commercial architecture, that means the jacket is certified to strict fire safety codes, allowing it to be safely run through the critical air circulation spaces of a building.
So it's built for the infrastructure, not just the AV rack. And I actually noticed the connectors have powered LED status indicators built right into the TX and RX heads.
Yes, so an installer knows instantly if they have a handshake.
Right, rather than guessing if a 500-foot run was successful and having to walk all the way back.
Exactly. If we connect this to the bigger picture, it fundamentally changes how architects and engineers can design spaces for high-end video. The old distance limitations are effectively erased.
And the installation is verified in real time. So what does this all mean?
Well,
for you, the AV professional or heavy-duty tech enthusiast, it represents a massive shift in economics and logistics. What used to require thousands of dollars in network repeaters is now a direct commercial-grade AV solution for $383.
Which is a huge drop from its $520 MSRP.
And it includes a 2-year warranty to back up that durability.
It completely democratizes commercial-scale AV architecture.
Exactly. We figured out how to tame the pressure of that data fire hose and carry it perfectly across 3 football fields. But it leaves you with this to think about.
What's that?
If we can already transmit uncompressed, pristine 8K data across 1,000 feet using detachable, affordable fiber optics, how much longer until traditional copper wiring is completely obsolete in our homes and cities?